So the question then is, how was the structure of matter discovered? How did this story unfold? And it's important to point out that virtually without exception, conceptual advances are created by new observations. And those new observations play an important part in changing the way the community views the basic scientific principles. And often this leads to a radical change in perception of how science and the scientific method define nature. And you'll remember from chapter 1 there was a famous example of this, and that involved Max Planck, who postulated the particle nature of light. And he deduced the particle nature of light by observing the intensity dependence as a function of wavelength of radiation emitted from a black body cavity. And the triumphant success of Maxwell's equations in the 19th century was one of the leading determination at the time of how physics worked and how light interacted with matter. So when Max Planck postulated that electromagnetic radiation was not a wave but rather a particle, most of the scientific community simply laughed off this as impossible. But what appeared to be impossible turned out to be the truth, because the blackbody radiation curve was what demonstrated very clearly that light had to be composed of particles. Now, there are other very important examples that we've looked at. This concept of caloric that carried through from the Greek to the Roman period to the Middle Ages, wherein heat was viewed as a substance, in fact, a liquid that was transferred from one body to another. In fact, one body that was very hot had a great deal of this liquid caloric in it, and a body that was cold had much less of that. But Benjamin Thompson clearly demonstrated that heat is not a substance. It represents a transfer of energy between two bodies transferred by molecular interaction. Copernicus demonstrated that the Earth did not exist at the center of the solar system, and that revelation took nearly 100 years for acceptance. It was much easier to prove because you could prove it with astronomy and the observation of planets, but nevertheless it took 100 years to be accepted. So we come then to the fact that through all of human history until the late 18th and early 19th century, matter was viewed as continuous. And the idea that physical matter around us was divisible into specific identifiable entities was rejected by scientific thinking until, as we will see, the year 1808, which was the crucial year that determined the future of all modern chemistry.